Hi guys, we are going to have another class about circuits that have series and parallel resistors, and they're going to be combined, and we have to get the equivalent resistance. So what do? Let's say that we have this circuit here, and for simplicity's sake, all the resistors are of 10 ohms, okay? So all of them, they are of 10 ohms. And where do I start? Well, let's see. Well, R1 and R2, this and this resistor are not in series because there's something in between. But R3 and R5, they are in series. And maybe you could say that R2 is in parallel with R3, but it's not because it's not sharing this connection. But after you combine these two circuits, we're going to have one circuit, one resistor that is going to be in parallel with this one. And also you can say that R4 and R2 are series or parallel because there's something here in between. So that's going to eliminate the property that it's in series. So what do we do first? Well, this thing here, we're going to do one big resistor. That's going to be combined. And what's going to be the value there now? Well, this used to be 10, but now it's going to be 20. And this one is also 10. And now after that, I got to combine. Now, okay, after that, I see that this resistor, this big resistor that I got here, it's going to be in series, in parallel with this one. So what do? I got to combine these circuits into one big resistor, and that's going to become something like this. I'm going to draw it again over here, and here we go. Alright, something like that. And this is the voltage source. This is 10. This is also 10. But what about this one? How do we calculate it? Well, let me see. Okay, okay. We're gonna use this calculator that I have over here. I'm gonna let me just arrange it just a little bit. We're gonna get the operation for that. We're gonna do the parallel between 10 and 20. So all you have to do is just multiply 10 and 20 and then divide by the sum of those two numbers, and we get 6.66. So this one is gonna be 6.66. That's going to be the resistance in this one. Now what's going to be next? Well, I see that this is connected with one connection. They share just one terminal between this resistor and this resistor, so that makes it in series. And all of these guys then are going to be in series. And all I have to do is just add these resistors. The result, the total or equivalent resistance, it's pretty easy to get because it's just 10 plus 10 plus 6.66. That's going to be 26.66 and so on. 6 dash actually. Anyways, let's continue over here. How do we solve this problem? It's pretty much the same as the other one. I gotta start with the things that I see that are clearly in series, and then I gotta do the parallels. So let's say again that they're all 10. So all of these guys, they're going to turn into one big resistor. This one is 10, 10, and 10, so that's going to become 30. And then here's two of them, 10 and 10. Then this is going to be one big resistor of 20. And then this, it's just 10. I don't need to change it. But then I see that this is going to become something like this. Let me redraw that circuit for you, so that we can have this more clearly explained. Let me just redraw this. So this is 30, this is 20, and this is 10. And then we have here 10 and then 10 again. Now all of these guys, I know that they are in parallel because they share the two terminals. This guy is sharing this terminal with this guy. So this is in parallel also with this. So all of these guys are in parallel. So I'm going to calculate that. Okay, so I got to do the following. I'm going to do 1 divided by 1 divided by 10 plus 1 over 20 plus 1 over 30. And that's it, 5.45. So this is going to be 5.45. That's going to be the result here. And all of this is going to become one huge resistor, just one resistor that has that amount. Okay, and that's going to be 5.45, what we just got. And this is going to be 10. This is also 10. So the equivalent or the total resistance is going to be the sum of these guys. Pretty easy to get. 10 plus 10 is 20 plus 5.45. That's going to be 25.45. And that's it. That's going to be the result for this circuit. Now let's do this one. Is it the same or is it something else? Oh yes, it is different. Okay, again, all of the resistors, for simplicity's sake, they're going to be 10. Alrighty then. So this is 10, 10, 10, and so on. I think it's easier than this one, or it's pretty much the same deal. Okay, so this is 10 and this is 10. So all of this is going to become one brick circuit. It's going to be 20. And then all of these, they're going to be one big resistor. It's going to be 20. And this is going to be 10. How do I know that this is 20? Because this is 10 and this is 10. They are in series. I got to add them and it's going to become 20. And this one is also in series, and it's in series with these guys, with these two. These two are in series, so I can add them and I get 20. And then I got to get this is a 10. And I got to get the parallel of all of these guys because they are evidently in parallel. So let's do that. I'm going to get the parallel 1 over 10 plus 1 over 20 plus 1 over 20 again. There we go. Okay, so that's going to be 5. So here's a big resistor. All of this, it's one resistor. And let me just redraw that for you. This is going to be that resistor, the 5. This one is 10 and this one is also 10. So the total or the equivalent resistance is going to be the sum of these guys because they are in series. So the result is going to be 25. 10 plus 10 plus 5, it's 25. Well, what about this one? Okay, so where do I start? Do I have anything in series right now? There's nothing in series, evidently, right now at this moment, but you will be seeing something that is in series, but right now we can't do anything in series. So I'm going to do first, I'm going to check this out over here, and I'm going to notice that this resistor is sharing this connection here, so they are connected, and the other connection the other terminal of this resistor, it's also connected with this other terminal. So they're sharing these two terminals. That makes it in parallel. So I gotta get the parallel of the two, and let's remember that they are both of 10 ohms. So I gotta get the resistance in parallel when we have 10 and 10. And there's a trick for that one. It's just gonna be the half. So I'm just gonna do it, but you're gonna see that it's also 5. So this resistor, this guy right here, it's going to be 5 ohms. And then I gotta do also the equivalent resistance for this one. Again, it's 10 and 10, so there's not much to do there. It's gonna be the same deal as over here. So this resistance, this parallel resistance, its value will be 5. What about these three? Well, that's going to be a little different. I got to just do this. It's going to be 1 over 10 plus 1 over 10 plus 1 over 10 because they're all of the value of 10. So the result for that one is going to be 3.33. Okay, so all of this, it's going to be 3.33. That's going to be the resistance that is equivalent for this section because they are in parallel. And then after that, okay, let's see what else we can do. Let's see, there you go. So then this equivalent circuit, it's right here in this resistor, it's going to be 5. And then these resistors, they're right there, 3.33. And this one is 5. There you go. So the total or equivalent resistance, RT or RE, it's going to be the sum of these guys. 5 plus 5, that's 10, plus 3.13. Isn't that 13.3? 3 dash or just 3, whatever. Well, that's the result for that one. Alright, let's do this next one. Whoa, it's kind of complicated, isn't it? Not really. Not really. Let's start with the series. Again, they are all of the value of 10. So I'm going to start with this one. I see that you have 2 resistors in series, so that's going to become 20. And then these 2 resistors are also in series. And 10 and 10 gives us 20, so this is going to be just 20. And all of these guys, these 2 are 10 and 10, so this is going to become one big resistor of 20. This is 10 and this is 10 as well. Okay, now what about this section? Well, guys, this is in parallel, so that means that this is going to be 5. Alright, so I'm going to redraw this circuit with the simplifications that I just did. I'm going to redraw it right there, each one of those resistors, more or less like that. There you go. And here's the other one, and the other resistor. That's right. So we have this one. That one is 5. This one is 10. This guy over here, it's going to be drawn over here. I don't have space for that, so it's going to be right here. This is 20. This guy is going to be 20. This guy is 10, and this guy is also 10. So what's going to be the next simplification? Let me change colors very quickly. I'm going to get some other color. How about that one? Okay, so this 5 and this 10, I got to simplify them. And 5 and 10, got to add them, and it's going to be 15. Why do I add them? Because they are in series. And that's the only simplification I can do until now. So what's going to be next? Let me go back to that other color. Let's say that one. Okay, so we have the blue color. There you go. And I'm going to redraw this circuit again with that brief simplification that I just did. But you're going to be like, teacher, you don't have to do that. It's okay, I'll do it. No problem. 5 plus 10 is going to be 15. So the purpose is that nobody will get confused or more confused. So this is going to be 20, and this is going to be also 20. 20, and this is 10, and this is also 10. Okay, so what do I do next? Let's change colors. I'm going to change colors to this one. So I see here that all of these guys, they are in parallel. So I got to get the parallel of these. And this is 20, 20, and 15. Let's calculate that. Let's see. I'm going to put this again over here. It's 1 over 20. It's 1 over all of these guys, right? You know what I'm doing here. It's the same as before. 1 over 20 plus 1 over 20 plus 1 over 15. And that gives us 5.99. Hey guys, how about we round off that to, how about we round off that to a 6? 5.99. Let's say that it's just a 6. So all of this is going to be 6. And this is 10, and this is 10. Should I redraw it again? Should I redraw it? I'm going to redraw it so that you guys can see what's going on. So all of this, all of these resistors became just one resistor of 6 ohms. So that's going to become this. And I'm going to redraw it here, right there. So this is 10, this is 10, and this is going to be 6. So the total resistance, it's going to be the sum of these guys, 10 plus 6 plus 10, that's going to be 26. And that's it. That's how you do it, guys. I hope you you don't have any problems with it, with the exercises. But if you do, I'll be here for your questions, for any doubts that you can have. And well, that's it, guys. Just be careful with the resistance. For example, one major confusion that I did address a while ago is that some students can say that, teacher, this thing, that's in series, but it's not in series. Again, I gotta iterate that again. I gotta remind you that it's not in series because, as you can see here, there's something else in between. That's not in series. So if it's like this, that's in series. But if something else is in the middle, it's not in series, it's not in parallel. That would be the big major confusion that could be stemming in these problems that you could see or that you could maybe get. Okay, so that's pretty much it, guys. You guys have a great day. I will see you later. You know where to contact me if you have any questions. I'll be here to help you out. Guys, have a great day. I'll see you later.